Today on the John Ankerberg Show, does advancing science refute or prove the Genesis 1 creation account? My guest is astronomer and astrophysicist Dr. Hugh Ross, who received his PhD in astronomy from the University of Toronto and did postdoctoral research at Caltech on quasars and galaxies. The James Webb Space Telescope is the largest and most powerful telescope ever launched into space. It was launched December 25th, 2021. Do new scientific discoveries of modern-day telescopes reveal scientific information that disagree with the creation account in Genesis chapter 1? To hear a professional astronomer answer these questions, who has followed the James Webb Infrared Telescope from the beginning, we invite you to join us. Welcome to our program. Our topic today is James Webb Infrared Space Telescope. Do you know it was the largest and most powerful telescope ever launched into space? It was launched December 25th, 2021. Guess where it orbits? It orbits the sun 1 million miles away from the Earth. And it's been studying every phase in the history of our universe, ranging from the first luminous glows after the Big Bang to the formation of solar systems capable of supporting life on planets like Earth. A lot of you were walking around on Earth with our cell phones looking at this. We never look up in the sky where the real show is at. Today, you're going to see about the real show. And we have astronomer and astrophysicist, Dr. Hugh Ross, that's been reporting, writing, and knows all about this satellite. So Hugh, tell me, what is the purpose of the James Webb Telescope?
Well, it's got multiple missions, but the most significant mission, and the reason why it was built,
And here it is,
was to explore what's called the cosmic dawn. The cosmic dawn is that era in the history of the universe when the first stars form, when the first galaxies form. It's the only optical telescope powerful enough to explore that episode, and that's what's going to tell us which of the different Big Bang creation models correctly describes the entire history of the universe.
Yeah, apart from James Webb, you've also got other little telescopes that have gone up there. I want to know, how close to the beginning of the Big Bang have you astronomers gotten in terms of looking at your research?
Well, we can't get that with the James Webb.
No.
But we can with millimeter wave radio telescopes.
And how close have you gotten?
We've gotten within 100 billionth of a trillionth of a trillionth of a second after the cosmic creation event.
So you are right on top of it.
We're actually watching the universe being created, and that's where we get the most compelling scientific evidence that a God beyond space and time must have created our universe and designed it so that we humans can live within it.
Yeah, and it circles around 1 million miles away from the sun. So you haven't got any streetlights that are bothering this little baby. And why is it built the way it is? What are we looking at here?
Well, it orbits 1 million miles away from the Earth so that they can actually use the telescope 24 hours a day. The Hubble, it's 23 hours a day. You get an extra hour by putting it in that location. And it's in a location where the light of the sun and the light of the Earth do not disturb its observations. You see that sun shield there? It's the size of a tennis court.
4 of them?
5 of them.
5 of them?
And that sun shield basically blocks out the light and the heat of both the Earth and the sun.
Because the sun would melt it, basically.
Well, we need to keep the receiver where all the light is being focused at a very cold temperature. That's how it gets its very high sensitivity. So it's important that the heat be blocked out. I mean, the temperature at the focal point there, it's only a few degrees above absolute zero, thanks to that solar shield that you see there at the bottom.
Where's the camera?
You have the light coming down on those mirrors, being focused to a secondary mirror, and that light now goes into the center. There's a little hole in the center, and that's where they're actually putting the camera.
Okay, and how long does it take for those pictures to be transmitted back to Earth?
Well, a million miles away, it means it's going to take about 5 seconds.
5 seconds to get back to Earth.
Right.
All right. What was the purpose of this machine and all the money that was spent to put it up in space?
Well, it's about 5 times bigger than the Hubble Space Telescope. It's infrared because when we look very far away, objects are redshifted. So they purposely made it infrared because that's where they could pick up the most light from these extremely distant galaxies. And again, its purpose was we want to explore that window that no other telescope was able to see, namely the first billion years of the history of the universe. So that's its primary mission. And it's already brought back stunning images that give us information about that time window we've never had before.
Okay, astronomers, your buddies, were trying to come to a conclusion. And from what I hear is that they're not getting the conclusion they wanted. The evidence is pointing a different direction. Can you tell us about that?
Well, the expectation was that the early galaxies would be like what we would see. We just extrapolate the galaxies we can see close up, that it would go all the way to the beginning. But astronomers knew that it was possible that the first stars are much more massive. In the universe today, the biggest star you can have is about 150 times the mass of our star, the Sun.
Which is a big star.
That's a big star. On the other hand, if you go very early in the history of the universe, all you have is hydrogen and helium gas. You have no elements heavier than helium except for a trace amount of lithium, and that allows even bigger stars to form. The mission of the James Webb, how big are those firstborn stars? And the early images are telling us those first stars, at least some of them, are much, much bigger than 150 times the mass of our star, the Sun. We now know that there's at least some that are more than 1,000 times the mass of our star, the Sun, which explains why we're finding a few early galaxies that are super bright and bigger than what we'd expect if the stars were all smaller than 150 times the mass of our star, the Sun.
In relationship to the Big Bang, what does this all show our astronomers?
What had not ever been done before is to test a key prediction of the Big Bang creation model, which is that at the very beginning, the universe has only one element, hydrogen.
Yep.
But as the universe expands, it goes through a temperature window where some of that hydrogen can be fused into helium.
Yep, the two together.
And then all the other elements are made inside the stars that are formed thereafter. And so one of the missions of the James Webb, can we find some pristine gas early in the universe where no stars exist, where we could actually test this prediction?
And you astronomers didn't think that was possible, but all of a sudden you got surprised.
Well, the feeling was that the James Webb wasn't powerful enough to actually do that test. What we've discovered was we found an early galaxy that had bright stars that were very big and very bright, and they illuminated a gas cloud that was in the halo of that new forming galaxy. And they looked at that halo illuminated by those bright stars and discovered, lo and behold, all we see is hydrogen and helium, exactly what the Big Bang had predicted. When we look at the universe,
Okay.
we see that it is designed at every single size scale.
Yeah, design is killing off naturalism.
It really is. And, you know, for decades, astronomers who were not Christians conceded, yes, when we look at the universe as a whole, we can see it's exquisitely designed to make life possible, and especially to make human life possible. What they did not know, which has recently been discovered, is that's also true of the right galaxy. We have to live in a special kind of super galaxy cluster, and within that super galaxy cluster, we have to live in a special galaxy cluster. There's over 10,000 super galaxy clusters in the universe. We live in the only one that has a distribution of galaxy clusters that would permit the existence of life. We discover we happen to be living in the only galaxy that has the just right features that would permit advanced life to exist.
Here's our spiral one, the Milky Way over here, isn't it?
That's the Milky Way galaxy. And what's interesting is that astronomers have been wanting to see, are there other spiral galaxies? We know life requires a spiral galaxy. Are there other spiral galaxies sufficiently like the Milky Way galaxy that it could be a candidate to have advanced life within it.
Let's slow this down for some of my friends, okay? In the middle there, you've got a black hole. And the
Right.
fact is, then you've got these spiral arms. What are those little bright dudes that are all in these?
Well, those little bright dudes that you see along the spiral
Yeah.
arms, we astronomers refer to them as maternity wards.
Okay. and
That's where new stars are forming. But what's unusual about our Milky Way galaxy, we only have a bunch of small ones. Spiral galaxies typically have a few really big ones and a bunch of tiny ones.
Yeah.
We don't have any big ones.
All right.
These are the 12 closest galaxies to our own Milky Way galaxy.
But they all have a problem.
They're all different. None of them have the symmetry of the spiral arms.
Yeah, look at this one over here.
Yeah.
The fact is, it is crowded over there.
Yeah, here's 6 more. That's our Milky Way galaxy down
here.
at the lower right. And you can see how different these best spiral galaxies are. Perhaps this one that's in the center middle comes the closest to matching our galaxy. In fact, here's a close-up that shows the two of them together, side by side. And what you notice is they look similar, but notice the spiral arms in our Milky Way galaxy are much more prominent than the spiral arms in UGC 6093. Also, this galaxy has got a really big supermassive black hole
You bet.
that's pouring out deadly radiation. And the spiral arms in this one are not symmetrical like they are in our Milky Way galaxy. And also you notice all those little maternity wards are small.
Right.
And our Milky Way galaxy has 10 times as much dark matter as ordinary matter. That's not the case. There really is no other galaxy. I mean, people often refer in the next slide to our Milky Way galaxy compared to the Andromeda galaxy. The Andromeda galaxy, the spiral arm structure is warped. That's because that M32 passed through the center of the Andromeda galaxy about 500 million years ago. And it has very, very much less dark matter than the case of the Milky Way galaxy. It's that dark matter that stabilizes the spiral structure. And the Andromeda galaxy has been gobbling up big dwarf galaxies throughout its history. The last time our Milky Way did was 11 billion years ago.
Yeah, you look at these pictures and it looks black out there. There's dark matter and there's cold black matter. Okay,
Well,
what's the difference?
Ordinary matter is made up of protons, neutrons, and electrons. So we're both made out of ordinary matter. What astronomers call dark matter is matter that's made up of particles that do not interact with photons, which is why you really have a difficulty seeing them. But we notice that this dark matter, it exerts gravity. So there's mass there. And the dark matter halo around our Milky Way galaxy, it's literally 1.9 million miles in diameter. There's about 5.5 times as much dark matter as there is ordinary matter in the universe.
It's a lot.
And in the case of our Milky Way galaxy, it's the super champion. 90% of the mass of our Milky Way galaxy is dark stuff. That plays a huge role in stabilizing the spiral structure. And because we haven't absorbed a big spiral or a big dwarf galaxy in 11 billion years, our supermassive black hole is 35 times smaller than would be the case if that wasn't what was going on.
Okay.
Well, here's actually an image
Yeah.
of our supermassive black hole. And it's not only way smaller than black holes and other spiral
Usually are,
galaxies,
yeah.
it's also at a time in its history where the only mass it's gobbling up are bodies the size of a comet or an asteroid, which means no deadly radiation is coming out during the human era.
So it's a protector.
Well, it's a protector. It's very small, that helps. But the second thing that helps is right now it's on a very constrained diet. So it's basically on a starvation diet. But because of that starvation diet happening only during the human window,
It benefits us.
we can launch civilization.
Okay.
So we also notice we're not only in a just right galaxy, we're orbiting a just right star. I mean, my colleagues, my peers in astronomy, for 65 years have been searching for a star sufficiently like the sun that it could be a candidate to support advanced life. We found lots of stars that are twins of one another. but we've yet to find a twin of the sun.
Yeah, you actually wrote a scientific article about Darwin didn't know about the luminosity of the sun, okay, when he created his deal on evolution. And when you do know about how the sun changes and the luminosity, how it changes, the fact it would have destroyed his whole theory, he just didn't know about it because it wasn't
nobody
soon
knew
enough.
about it at the time of Charles Darwin. Now that we know that the sun's energy comes from nuclear fusion, we realize that the sun, like all stars,
Evolution is dead.
gets brighter as it gets older and older, which means that in order to keep the temperature on the surface of the earth optimal for life, you need a creator that takes life away from the earth, replaces it with new life, where that new life is more efficient at pulling greenhouse gases out of the atmosphere. So as the sun gets progressively brighter and brighter, the atmosphere becomes less and less efficient in its capacity to trap heat from the sun, keeping the temperature optimal on the surface of the earth. But here's the thing that kills Darwin's theory. Only a mind that knows the future physics of the sun would know which life to remove from planet Earth and which new life to have replaced that life. And it's actually in Psalm 104. It's a property of all life to die off, but God recreates and renews the face of the earth, but he does it in such a way to perfectly compensate for the brightening of the sun.
Okay, how old is our sun? Because at the beginning and at the end, you got big problems. And where are we on the age limit here?
Well, it's 4.57 billion years old.
Okay.
It has a capacity to keep burning through nuclear fusion for about 9 billion years.
And where are we at?
We're about halfway through that burning process.
Which is the perfect spot to be.
It is, because when you're halfway through, that's when the star is most stable in its luminosity. And our star, the sun, has a luminosity stability that's 5 times superior to the second best star we've ever found. And only a star that's extremely stable would allow for human civilization to be global and high technology.
Yeah.
It's not just that we have the just right star. Now that we've discovered planets outside of our solar system, we now realize that it's not just Earth that has to be fine-tuned. All 8 planets that are in the solar system must be fine-tuned in order to make life possible, advanced life possible on Earth. So when our family celebrates Thanksgiving, we thank God for Mars, we thank God for Neptune, we even thank God for the asteroid and comet belts, because we have 5 asteroid and comet belts that likewise have to be exquisitely fine-tuned to make advanced life possible on Earth.
Well, they protect us, don't they?
They do. They also provide us with the water, because our planet Earth loses a tiny amount of water to outer space. The tiny amount we lose is perfectly replaced by these small comets that come in and hit the Earth and basically evaporate before they get to the surface. Comets are 85% frozen water. We also get heavy elements from the asteroids that sustain our civilization. And when we look at planet Earth, we see that over 500 distinct features of the Earth must be fine-tuned in order to make possible advanced life on Earth. And we have to have a just right moon and a just right Earth to set up a coupled magnetosphere that would prevent the early sun from sputtering away all of our water and all of our atmosphere. There's nothing like it anywhere else in our galaxy. This planet, relatively small, orbited by a really big moon, where the 2 bodies are separating from one another in such a way as to make life possible on planet Earth for 3.8 billion years and allow humans to exist.
All the stuff we just talked about are design features that only apply to our Earth. And it's killing your atheistic astronomer buddies and astrophysicists.
Well, what they're now being confronted with, it's not just the universe's design, every different cosmic size scale, whether you're talking about the cosmic web, the galaxy clusters, the local group of galaxies we're in. You can go all the way down to the fundamental particles.
Yep.
No matter what size scale you look at, you see overwhelming evidence
Cells in our body.
that has been designed to make our existence possible. It just shows me the degree of care that God has for humanity, that he didn't think it was too expensive to make a universe with 2 trillion galaxies, and carefully worked it over 13.8 billion years, so that not only could we exist, we could thrive and develop the civilization, develop the population of billions, so that billions of us could hear the gospel message and receive redemption from our Creator and have a pass to go into the new creation where we're going to live for the rest of eternity with our Creator.
You did not grow up in a Christian home. You had no church in your city. You didn't know a Christian until you actually went to Caltech for postdoctoral work, and that was the first time you actually met a Christian. But there were two guys that when you were in the 7th, 8th grade that just brought in a box, and you don't know what was in that box, but it actually turned out to be a box of Gideon Bibles. You grabbed one because they were all free, and you didn't read it for 6 years. You put it on your shelf, and when you did, what did you find out, and why did it lead you to Christ?
Well, I didn't have a reason to read that book until I recognized the universe has a beginning, therefore there must be a beginner. I need to find that beginner. And that was one of the books I looked at to see if it actually told me who that beginner was. Yeah.
And that creator, that beginner, actually, he visited our planet.
Yes.
And he made a way for we people, human beings that he had created, to get to know him personally. In brief, what is the message of the gospel?
Well, what impressed me about Jesus of Nazareth, he told in front of a large crowd, included his mother, his brothers and sisters, I am morally perfect. And they agreed with him. And it says, no one has ever been able to make that statement. No one is good but God. And this man, Jesus of Nazareth, indeed must be the creator of the universe. And he sacrificed himself so that I could basically trade my moral imperfection for his moral perfection. That was too good of a deal to turn down.
And he said, but as many as received him, to them he gave the power to become the sons of God, even to them that believe on his name.
Right.
And whosoever shall call upon the name of the Lord, he'll save them. He'll
Right.
change them from the inside out. Hugh, this has been terrific, and we're going to probably refer back to this in our next program, but it's amazing what God has shown us, and it's all around us. And again, what knocks me out is most of our young people are watching their cell phones, and this, if you get your telescope, is all around us. And now we got satellites that are even showing us more and more that prove the existence of God and the care that he has given for humanity. And there's no place else in this massive, massive, massive universe of ours that you find this. Only here on Earth. Thanks for being with us today, folks, and I bet you that you are enjoying this, and we're going to show you a little bit more next week, but the fact is, stay tuned. I got a personal message for you in just a minute.
Stay tuned. John will be right back.